The consensus piece was really fun. We got to like basically use rows, which was like assigning rows and throws, which were like really assigning signing schemes on a communication protocol, like more turning it into a consensus mechanism, being able to like achieve instant finality for these blogs. And also like my name is Amine and I'm a CTO as Arch Network. So the reason we chose eBPF and went with like the Solana-like account model is if you think about UTXOs, they're inherently like parallelizable. Like inside Bitcoin nodes, UTXOs are independent from each other, and you can also like process Bitcoin transactions in parallel. And that fits really well with Solana's programming model of independent state and parallel execution. And it doesn't really with the EVM of like this global state. Like imagine if we did this with the EVM, we would need to basically chain everything together into one global state, into one UTXO. And that would be a really horrible experience. Again, like you need to wait for block times, you need to chain a lot of transactions together. If one transaction gets rolled back, all subsequent transactions get rolled back. You can't do the DAG for the rollback mechanism, and everything. Yeah, just becomes much slower, much clunkier. That is why we chose to go with the eBPF and Solana's account model. There are some intricate differences. It's not just like a copy paste. You can just copy and paste your programs. Like for example, we modified the account info struct, basically added a UTXO field that is basically used to anchor the state transitions for the account to the Bitcoin asset transfer that is happening. Uh, which is and this anchoring mechanism is basically what tells the rollback what transactions are dependent on each other. Because you can't have like if you're using one account in two transactions, that's are sequential. You can't have the state transition from the second transaction is only valid if the first state transition from first transaction is valid. So this like creates this dependency that is also enforced by like Bitcoin transactions. The actual like functions that you're using, they're very similar to Solana. There's like separation of like the business logic and like the data structures. But we also have like a couple added syscalls to basically like be able to read Bitcoin data and like sign transactions, sign inputs. The UTXO that is an account anchor, as long as like you're aware of it and you understand that a state transaction needs to be anchored to the Bitcoin transaction, it doesn't really make much of a difference. I would say the additional parts of the Bitcoin, like being able to read the data from Bitcoin and signing transactions is core to like what is different from Solana. You can do like pretty much everything you do on Solana. You can do like cross-program invocations. Pretty much all the syscalls are already there. We have like the built-in programs, VPF loader, stake and vote. Yeah. The funnest part is working on networking and working on the consensus. The consensus, we're using like Gossip for networking, and that was fun. It's like dealing with like scaling problems and like how do you like architect a system in a way that it like scales with the number of validators, like consumes the least amount of bandwidth, making like things efficient. Also the consensus piece was really fun. We got to like basically use rows, which was like assigning rows and throws, which were like really assigning signing schemes on a communication protocol, like more turning it into a consensus mechanism, being able to like achieve instant finality for these blogs. And also like there were some optimizations here and there that were fun with like optimistic execution. that mainly was like how do you basically like optimistically execute blocks and basically be able to send like the broadcast the blocks beforehand before we need them to like basically maximize the throughput of the chain and use all the bandwidth on each node. So yeah, that was fun as well. Yeah, there were definitely like some interesting challenges here and there. So how do we like scale the database? How do we handle like changes to the database with the rollback mechanism? That was also quite challenging.